In this video, we're going to add a handful of transforms to our toolbox that will enable us to recognize our small signal patterns in even more circuits. The first transform we're going to talk about is useful when an annoying element is in parallel with an otherwise appealing looking small signal model. I've drawn a circuit above that looks like an annoying resistor in parallel with an otherwise super reasonable right-left model. So we could just use the Thevenin resistance we know for this if the annoying resistor weren't there. But when we derived our result for this small signal pattern, we had assumed that all of I in passed through R left, and that's not true because of the annoying resistor. So we're going to analyze this circuit by changing what circuit we're looking at. First, we're going to find RTH1 by looking into this left-right pattern, and then we're going to observe that RTH is equal to RTH1 in parallel with R annoying. The takeaway is that you can just peel off parallel elements to look at a branch of interest, and then add them back in parallel at the end of your analysis. The second transform we're going to see has to do with GM generators with inconvenient control variables. The circuit on the left looks almost like our 1 over GM pattern, but the annoying resistor means our control voltage isn't between Vin and ground. We can fix that by redefining our control voltage, which we see on the right. I've made two changes in the circuit. First, the control voltage now runs from Vin to ground instead of just across R1. But I've made sure we wind up with the same current in the GM generator by defining an effective GM down here, which is given by a voltage divider between R1 and R annoying applied to GM. Second, I've reversed the direction of the current source by reversing the polarity of the control voltage. Here the negative sign was closer to Vin, here the positive sign is closer. And when we flip this up and down, that has the effect of identically flipping this arrow up and down. So you can clean up the signs in your equations by making that substitution. In addition to making our life easier, redefining the control voltage like this gives us a bit of physical insight. This divider is indeed reducing how much VC changes when Vin changes, so you can think of it as making GM effectively smaller. This is a super common transform. We've already seen it at work in our emitter-follower output resistance, where R1 was R pi and R annoying was the source resistance. So this division effect is why we add Rs over beta to 1 over GM in the emitter-follower R out. So in summary, we learned two tricks in this video to help us extend our small signal patterns. You can take inconvenient parallel elements off of your analysis and then add them back in parallel at the end. You can also redefine the value of GM in order to use more convenient control variables and eliminate nodes in your circuit.